Hello everyone, I'm Ayşe. Today I'm going to present my project. The name of the project is Optimize LLMs with Llama Fine Tuning. So let's start it. So, what is our goal? In this project, I fine tuned the Tiny Llama model using the LoRa technique to build a system that can both detect user intent and generate human-like responses based on travel-related messages. Accurate intent recognition is crucial here. It ensures the assistant provides the right answer and also triggers the correct automated backend actions when necessary. In this project, I worked with a dataset consisting of various user queries related to travel. Instruction, a question or request made by the user about a travel-related topic. Category, the general topic that the request falls under, like booking. Intent, what the user is actually trying to do. Response, the ideal example response the assistant is expected to give in that situation. The project aims to fine-tune the tiny lemon model using LoRa to build a travel assistant. The model is initialized, LoRa config is set, and CFD trainer handles training. After training, the model generates a response stored in model response. Let's talk about solution part. This section installs the essential Python libraries needed for fine-tuning the final Llama model. TRL used for training transformer-based models. TF-Keras, a standalone version of the Keras API built on TensorFlow, sometimes required as a dependency. PFT enables efficient fine-tuning of large language models using techniques like LoRa. The QFlag expresses installation messages for a cleaner output. These libraries are used for following purpose: loading pre-trained models, managing and preparing datasets, setting up LoRa parameters for the fine-tuning, running training workflows, and organizing and sampling data. This line loads to Bytex travel chatbot dataset for training. Each record in the dataset generally includes instruction, the user's input or question, intent, the labeled purpose behind the query, response, the ideal reply the chatbot should return. The code above organizes the dataset by intent using a dictionary. This approach ensures balanced sampling so that each intent has fair representation during training. This part calculates how many samples to include per intent class. Prevents one intent type from dominating the dataset, helping maintain class balance. And this code part randomly draws an equal number of examples from each intent group, reduces the risk of overfitting to frequently occurring intents. This part converts a subset of balanced data into a Hugging Face dataset. Uses only the first 50 records for a quick and inexpensive fine-tuning trio. This part merges instruction, intent, and response files. Creates a single string field called conversation to simplify input formatting during training. Llama is a lightweight, efficient, and low-cost open-source language model. Automodel for Casual LM is the class used for building models that generate text like chat responses. Since the model has no predefined PID token, the EOS token is used as a substitute for padding, which is common workaround. This runs just one training step useful for testing the pipeline. Four samples are processed at each step for this line. And these lines gradients are updated after every mini batch. This line's max growth norm equals 0.3 prevents exploding gradients by applying clipping. And this line specifies the input field for tokenization. And finally, output there defines where the model checkpoints will be saved during training. R equals 12 sets the rank for low rank decomposition. Higher values allow the model to learn more parameters. Target models LoRa is applied only to attention layers to reduce overhead. So, why use LoRa? Significantly lowers memory and computation requirements, only modifies a small efficient subset of the model weights. Safety trainer is set up using the pre-trained model, the processed dataset, the LoRa fine-tuning configuration, and training arguments. The training process is started using trainer train. In this setup, the model is trained for just one step, primarily to test the full pipeline. This code part is converts the user's input message into token IDs, uses the fine-tuned model to generate a response, removes the input portion to isolate only the newly generated text, decodes and stores the final output as a model response. So our output looks like this. Since the training was limited to a single step, the model hasn't learned much. As a result, generated outputs are often empty or black, composed of unrelated or random words, low in quality or relevance. Sum up, throughput this project, I worked within the Hugging Face ecosystem using tools like transformers, datasets, and TRL, along with PFT for efficient fine-tuning with the LoRa technique. The datasets labeled and provided by Bytex was organized by intent and balanced to ensure fair training. Instruction, intent, and response fields were merged into a single conversation string to for inputs. I fine-tuned the lightweight tiny llama model using CFD trainer with LoRa, which significantly reduced the training costs. After training, I tested the model with a simple query. This approach allows quick, affordable adaptation of a language models using small amounts of the domain-specific data. Thank you for listening to me. That's all. Goodbye.